There's one type of problem that might be kind of unfamiliar to you. I would expect that it would be fairly unfamiliar to most people, and not everybody would necessarily be able to figure out how to approach it. It kind of looks like, to a lot of people, it just looks kind of incomprehensible. So, we have an equation, x plus ky equals 0, and kx plus y equals 0, where k stands for some number. Of course, that means we're going to have the same number here as we have here. And the question I have is, how many solutions are there to this equation? Okay, or to this system of equations? Well, the answer to how many solutions depends on the value of k. For example, okay, if k equals 0, the system is what? Now at this stage you should pause the video and answer that question for yourself. Okay? What's the system, and how many solutions would it have? Well, if k is 0, then the system is x plus 0y equals 0, and 0x plus y equals 0. Just x equals 0, and y equals 0. So that's easy. Now let's suppose that, what if k equals 3? The system is what? X. And again, you should pause, write this out, and think it through before you watch me do it. And you should have done that already. Of course, there's no way for me to tell whether you did or not, and that's totally up to you, but that's the way to learn. Okay, the system is this. Okay? Now, I will simply say that this system turns out to be inconsistent. Okay? If we reduce it, well, actually, it's not inconsistent. The solution, again, is as a matter of fact, x equals 0, y equals 0 is always a solution to this system. Now, is there any value of k that makes this system, that gives this system more than one solution? You can verify that this is the only possible solution. If you reduce the equation, the reduced matrix, and what happened to my purple chalk that I use for, don't have to stay consistent with colors because I'm not going to color code everything, but you're going to get one zero 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 1 0. Okay, if you reduce this, because if you subtract 3 times the first from the second, you're going to get rid of the x but not the y. So you're going to have a 0 and a number here. Well, you should reduce the matrix. Okay, now is there a case where you have more than 0 solutions? Well, thinking about the matrix can give us a hint. You don't really need to use the matrix to do this, but let's just say we write down this matrix. Okay, we have x, coefficient is 1, k, 0, k, 1, 0. Okay, so what do? We subtract k times the first row from the second row. And I'm not going to actually write that down just yet, just because I don't happen to have the right colored chalk in my hand. But we get, of course, the first row we repeat, and then it's the second row plus negative k times the first. So, yeah, I guess I better write that down just so you keep it. Okay, so this is the first row, and this is the second. Let's do it this way, negative k times the first plus the second. I didn't leave myself a lot of room here. I do that a lot. Okay? Might be a little hard to read rough board, but I think you get the idea. So let's see, negative k times 1 is negative k. We add that to k and we get 0. Negative k times k is what? It's negative k squared. And we add that to 1, we get 1 minus k squared. 0. Okay? Now it's clear that whatever k is, I'm not going to formally do the row operation. But we could certainly take 1 divided by 1 minus k squared. We could take negative k over, what do we multiply this by? We've got to multiply this row by something that gives us k, right? So yeah, negative k over 1 minus k squared. That's what I started to say, but somehow my mind kind of lost the picture. Okay, we get this. And of course this could lead to 0, 1, 0. Okay? Now, how would we get from here to here? Here we would have to multiply the second row by 1 over 1 minus k squared, right? So this would be the second row, well, 1 over 1 minus k squared times the second row. And of course we repeat the first row. And I guess, write out the operations here since I've got a little room over here. Negative k, sorry, this is just the second row repeated. And this is negative k over 1 minus k squared times our first row. You can think about that and ponder it if necessary. Okay. Now down here we have this. Okay. And this works just fine. So it seems that this matrix always reduces to this. But it's not so. Can you think of why it's not so? Well, this only works. Let's use our, come on, come out of there. And I've written that wrong. It's only possible if the denominator here is not 0. Okay? If 1 minus k squared equals 0, we're stuck with this matrix. 1, 0, 0, 1, 0, 1 minus k squared, 0. But of course, if 1 minus k squared is equal to 0, 1 minus k squared is equal to 0. And that means our matrix is 1, 0, 0, 0, 0, 0. Meaning that y can take any value because y is unrestricted. And whatever the value of y is, x is 0. And that seems inconsistent. And actually it is. Well, we'll let you puzzle that. There's something going on there. I'll probably follow it with another video because I don't want to stop and think about it. Okay, well, think about what it means if 1 minus k squared is equal to 0. What's the value of k? Okay, and then what would your system be for your value of k? Or if there's more than one value of k, what would the value of the system be for each value of k? So I'll continue this in a minute, but I do want you to stop and think about that. It's very clear now what's going on.